Okay, so from time to time, the question comes up is what is a modified servo? For most robotics where you have the wheels go round and round and round and round, you're saying, well, how can you do that? Servo is actually designed to only go at most from 0 to 180 degrees. Actually, most hobby servos, if you have a remote controlled airplane or whatever, and you're playing with your thumb controlled controller, it actually only goes 90 degrees. What can we do? How can we make this a robotics control? So here we have a fully functional Futaba servo. This is as it would be if you just bought it from any store. I'm gonna kind of take it. Oh boy, I didn't want to do that. I'm gonna take it apart. The gears have sort of fallen aside, which is kind of a bummer. Don't worry, I won't sell it to any of you if you decide to buy an unmodified servo. And what I really want to show you is what happens on the electronics side. So I'm going to put this gear aside here very carefully. And perhaps I'll pull this shaft out. This is a bit of a bummer. I'll put that back in there. Perhaps I'll deal with this later. Let me go ahead and pull this out, the electronics. Okay, here we go. And I'll fix that for myself later. The electronics. You see this is a variable resistor. It's very much the same as you would have on the volume control of your stereo. If I turn it counterclockwise some distance all the way to the stop, the volume would be 0. If I turn it clockwise some distance, the volume would be on max. It's got some flats, which makes it easy to orient. And if I go back and forth, the volume goes up and down. Okay, so this is used to determine where your servo is. You can imagine with these gears that are connected, as the servo rotates clockwise and counterclockwise, it's going to spin these gears back and forth, and it's going to cause this shaft to rotate back and forth, and it's going to send a value out to the electronics. It's going to say, whoa, 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 I'm at a particular point, and it's time for me to stop. Or I'm getting close to a point, and it's time for me to slow down. So on a modified servo, like this one, we have all the same gearing here. But the biggest difference is that the variable resistor is gone completely. We've cut it off. I've put 2 resistors of the exact same value in its place. So whatever they are, let's say this is 10,000 ohms and that one's 10,000 ohms. So they're exactly the same. So that therefore, when the motor is, if the servo is off to, for example, the 0 position, and I'd say, well, what I want to do is I want to go to the 90-degree position. So the motor then begins to turn counterclockwise. And as it does, it says, whoa, I'm really, really far away, because according to my resistors here, I'm at 0. So it tries very frantically to get closer, 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 closer. All right? But it never gets there because the resistors are still telling it it's at 90 degrees. So it goes really quickly in the clockwise position. Okay? Now imagine if I had said, well, what I really want to do is I want to put it at, say, 80 degrees. Okay? Or 85 degrees. Well, 85 degrees is really close to the 90-degree position, which means it's really close to these 2 resistors equating each other. So instead of going really fast, it actually goes kind of slow. It says, well, I'm already close. So it moves slowly toward this center position, which it never reaches. So the motor continues to move slowly and slowly and slowly, trying to get there. If I put it at, for example, the 90-degree position, I send a pulse that says, hey, let's go to 90 degrees. Well, 90 degrees is already what the resistors are set for. They're both equated. So it says, well, all right, so that's equal on both sides. So the motor stops. It doesn't need to move at all. Let's say I go to 100 degrees. Well, 100 degrees is a little bit past 90 degrees. So it says, well, I'm already kind of close, because remember, the variable resistors removed, and these two are already equated. The resistor on the right and the resistor on the left are already equated. So it says, well, I'm already really kind of close. So it strives to slowly move back to the 90-degree position. And of course it never gets there, so the motor slowly moves counterclockwise. And then if I go ahead and put it all the way, so I say, well, let's go all the way to 180 degrees. Well, 180 degrees is very far from the fixed resistor positions where they're both equated, and it struggles with all of its might to make it to the 90-degree position. So as fast as it possibly can, it moves counterclockwise to try to get there, but it never does, because the resistors are fixed. They've been removed. So these two are always telling it, no, 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 you're not there yet. And it tries and tries and tries and tries. So because of the fact that the variable resistor has been removed, and we put in two fixed resistors of the exact same value, that means that the motor will always try to achieve a position which is relative to this. So if I'm at 180 degrees, it's going to go quickly to try to get to the middle, which it never achieves. If it's kind of close, it's going to go slowly toward the middle, which it never achieves. If it is already set at the middle, it will stop. It will not move at all. If it's slightly to the left of center, it will try to slowly move towards center, but it will never achieve it, so it'll continually move slowly. And if it's way off to the left, or very far counterclockwise, it'll go as fast as it can towards center, which it will never achieve because the resistors are fixed and this variable has been removed, and it'll constantly spin fast and fast. So therefore we can go variable speeds by simply removing the fixed resistor, or I'm sorry, the variable resistor, and putting in fixed resistors into this electronic circuit. So hopefully that adds some clarity to how a modified servo is used in robotics. Thank you.